Designers currently grapple with complex design situations that often require an ecosystem of solutions that not only address the core design goal, but also address the sub-problems that result from their design intervention. However, this is not a simple task. Designers tend to fixate on the most apparent design goal and solutions without considering the design situation holistically. If we consider this phenomenon with a concrete example of the design task reducing petroleum consumption, the designer is first thinking of using renewable energies, such as wind energy, solar energy, and using electric cars that is powered by these renewable energies instead of petroleum. Now, the designers might think he has successfully reduced petroleum consumption and solved the design task. However, every proposed solution has sub-consequences that the designer might not have considered. For example, while electric cars are great, have the designers considered the potential pitfalls such as the inconvenience in charging and the difficulty of long-range travel? To help designers consider their design situation more holistically, we present CausalMapper, a mixed initiative system that leverages the generative creativity of large language models and design representations to help designers systematically broaden their understanding of a design space. To start using CausalMapper, designers first specify the design goal: lower petroleum consumption to reduce greenhouse gas emission. Designer can also add solutions they have in mind to resolve the goal with the add function. Here, two solutions are added. After designers added their solutions, they can use suggest function to consider potential alternative solutions. From the list of suggestions, they can accept the suggestions that they think are relevant for their design situation. Here, use public transportation is added. The accepted nodes can be further edited for clarity. Now we have a few solutions to achieve our design goal. But will our proposed solutions work when deployed to the real world? By selecting one of the solutions, CausalMapper suggests potential problems to consider and add. Here, 3 problems of electrical cars are added related to the range, the inconvenience of charging, and the pollution during battery production are added. As an attempt to solve the problem of having limited range, the designer added the solution: build more charging stations. To validate his solution, the designer can select the proposed solution and utilize suggest functionality again to uncover potential pitfalls. Through this iterative collaborative exploration between large language models and the designers, CausalMapper allows designers to go beyond the most apparent problems and solutions to consider the design situation more holistically. For example, while using electric cars can reduce petroleum usage, some problems have to be considered. Here we focus on the problem of limited range. But other problems such as charging inconvenience and pollution from battery production can also emerge. Similarly, when considering renewable energy as a replacement for petroleum, the designer should keep in mind that adapting to renewable energy can require significant change in infrastructure. In the future, we intend to formally evaluate CausalMapper with design students to better understand how CausalMapper affects their thinking process in the spatial exploration of the design space.